This is a circle. This is its center. If I draw a shape inside of my circle that looks like this, then this arc DC, subtends angle A and it also subtends angle B. Both angles are at the circumference. So we say angles subtended by the same arc at the circumference are equal. This is part 2 of Theorem 4. An arc or a chord of a circle subtends equal angles at the circumference, angles in the same segment, or angles subtended by the same arc. O is the center. O is the center. A, B, C, D, these points are points on the circumference. So we are required to prove that angle A, this angle, is equal to angle B, this angle. Now remember, in our previous video we were asked to prove that angle D is equal to angle C, and we used this arc, right? But in this one, angle A and angle B are subtended by this arc DC. Arc DC subtends angle A at the circumference, and it also subtends angle B at the circumference. So let's prove that angle A is equal to angle B. Proof. Construction. Now this time we are going to join DO because we are constructing from arc DC. So we join DO using dotted lines, and we also join CO. And now we have created angle DOC, and DOC is also subtended by arc DC. So now arc DC subtends angle A at the circumference, and it also subtends angle B at the circumference. At the same time, due to our construction, it subtends angle O, and angle O is at the center. And we know from the previous theorems that an angle subtended by the same arc at the center is twice the angle that's subtended by that arc at the circumference. So we say angle DOC, angle DOC is twice angle A. Why? Angles at the center are twice the angles at the circumference. Now again, arc DC subtends angle B, and angle B is at the circumference. So we say angle DOC is twice angle B. Why? Same reason. Angles at the center are twice the angles at the circumference. Now since angle 2A is equated to angle DOC, and also angle 2B is equated to angle DOC. Since both angles are equated to something similar, then we can equate the two angles. Angle 2A is equal to angle 2B. So we need to get rid of the 2. So we divide by 2 on this side, and we divide by 2 on this side. This 2 cancels with this one cancels with this one. Then we are left with angle A is equal to angle B. And now we have proven that angle A is equal to angle B, meaning arc DC subtends equal angles at the circumference. Now Theorem 4 has what we call corollaries. Now these are different ways the theorem can be used. So the first corollary is when you have equal chords and they both subtend angles at the circumference, then those angles are equal. So we say equal chords subtend equal angles at the circumference. We say equal chords equal angles at the circumference. Then the second corollary states that when you have two chords that are equal in length and they both subtend angles at the center, then those two angles are equal to one another. So we say equal chords equal angles at the center. Then the third corollary of Theorem 4 is when we have two circles that are equal in size. So these two circles are exactly the same size, and one arc in one circle is equal to one chord. This is a chord. An arc is this one. One chord of one circle is equal to the other chord in the other circle, right? And each chord in each circle subtends an angle at the circumference, and the other chord subtends its angle at the circumference in its own respective circle. Then these two angles are equal to one another. So we say equal circles, equal chords, equal angles at the circumference. So yeah, this is the end of the video. Thank you for watching.
It's easy to see when you look at me. If you look closely, Mystic don't back down. Subscribe to this channel if you haven't already, so that you can get that A in mathematics.
Leave a comment down below if you have a question. Mystic will make sure you get the answer.
Leave a like and share this video with your friends, so that we can all be good. Thank you for watching.